Alright, in this video we're going to be going over the Access Communications Exam Prep study guide chapters. So let's start with Network Video, Chapter 1, 2, 3, 6, 7, and 8. Alright, here's Chapter 1, Network Video, Overview, Benefits, Applications. So network video is IP-based video surveillance. The network is carrying power to the network video devices through Power over Ethernet PoE technology. The network video system allows video to be monitored and recorded from anywhere on the network, whether it is a local area network, a LAN, or a wide area network, WAN, such as the internet. So Access Communications sells these devices, IP-based, or devices, network devices, cameras, audio modules, wearable equipment that are IP-based that can work on local area networks or the internet. So there's a lot of benefits obviously from that. High image quality, remote accessibility, video analytics, future-proof integration, scalability, flexibility. You have PTZ cameras, point tilt zoom. They have technology built into the cameras like light finder for very dark areas. They have all sorts of technology like object recognition, some early AI stuff, license plate recognition, people counting tech built in. So another benefit is it's cost effective. Secure communication. Username password authentication, IP address filtering, authentication using IEE 802.1x, auth, data encryption using SSL, HTTPS, or VPN, increased security. So there's a lot of applications: retail, transportation, banking, finance, city surveillance, education, government, healthcare, industrial, critical infrastructure. All good applications for these access devices. So what is a network camera? This is chapter 2 now. Talked about this a little. So these are IP cameras that can send video or audio over a local area network or the internet. So this camera has its own IP address. It's connected to a wired or wireless network. Definitely recommend a wired for faster connection. I mean, we're talking about live streaming video, so that has a high bit rate. Speaking of that, though, Access does have really great compression technology that's not just theirs, but standardized across the video industry. H.264 compression, and Access has their own like zip stream technology that also helps compress video, compress that bit rate. Network cameras are powered over PoE. Access cameras are installed on the network through the Access Companion or Access Camera Station. Video management systems that automatically detect and configure the camera. Access Device Manager is useful for large installations to configure multiple cameras. You can change the configuration there in Access Device Manager for multiple cameras. Access Camera Application Platform, ACAP. This is an open application platform for a broad range of industries and use cases. Enables analytics applications accessible from Access website or third parties that can run and be installed on these Access devices. So that's Access Camera Application Platform. There's APIs. VAPIX, VAPIX is Access's API interface. And then ONVIF is a global open industry forum founded by Access, Bosch, Sony in 2008. So ONVIF is a open industry protocol or conformant, gives so I'm not really sure what this is, but most Access Network video products are ONVIF conformant, and that is a global open industry forum founded by Access, Bosch, and Sony in 2008. The aim is to standardize the network interface for network video and access control products of different manufacturers to ensure greater interoperability. Gotcha. So it's all about interoperability between different companies. Camera features for handling different scenes. They have WDR mode, wide dynamic range. This is when you have maybe a video with both bright and darker parts in the same image. WDR will help brighten the dark parts and unbrighten the really bright parts. Light finder technology, this is really good with color to effectively identify people, vehicles, and incidents. Cameras with light finder technology have extreme light sensitivity, can deliver day mode color images in as little as 0.08 lux or lower. So really good in the dark and identification in the dark light finder technology. Day-night functionality using infrared, an automatically removable infrared cut filter. There's built-in IR illumination for dark rooms. IR is not visible to the human eye. Camera sensors can detect it. The built-in IR lights, LEDs in the cameras can be adjusted. There's optimized IR technology, combines camera intelligence and sophisticated LED technology. Extremely efficient heat management, use of long range, high quality LEDs. So it's for assuring an even illumination in camera's variable field of view and difficult conditions. Lenses with a low f number means higher light gathering capability. Automatic iris control. So DC iris, P iris, or IC iris lens. Automatically adjustable iris is recommended. Cameras with P iris or IC iris, ICS, lens have better iris control for optimal image quality in all lighting conditions. So the right resolution, higher resolution, more bit rate, better quality though, a lot better quality with higher resolution. Thermal imaging allows detection in darkness, smog, or fog. Electronic image stabilization, EIS. This is good in like a metro station where there's lots of vibrations, a busy road. This technology employs a stabilization method. So there's outdoor ready cameras. Can be even in harsh climates. Focused at delivery. Remote focus and zoom. A varifocal camera with remote focus and zoom eliminates the need to manually on-site adjust the focus. So remote focus and zoom eliminates the need to manually adjust on site. Remote back focus. You can adjust the focus remotely from a computer. 3-axis camera angle adjustment. An axis dome camera is designed with 3-axis angle adjustment that allows the lens holder to pan, tilt, and rotate. You can also get vertically oriented video this way with corridor format. Enables a fixed camera to provide vertically oriented video in a 9:16 aspect ratio. With the dome camera, this is achieved by first rotating the lens 90 degrees, or with a box or bullet camera positioning it on its side, then rotating the video image back 90 degrees in the camera's webpage. Gotcha. Straighten image processing tool, which makes it possible to digitally correct slight skews in image rotation. Pixel counter shows the frame's width and height, helps ensure video resolution has sufficient quality to meet goals such as facial recognition identification. It is 80 pixels a foot for identifying a face in challenging conditions. So there's box cameras, bullet cameras, dome cameras, onboard dome cameras, discrete panoramic cameras, modular cameras, PTZ cameras. So PTZ has a lot of intelligent functionality, guard tour, preset positions, multiple preset guard tour recorded, auto tracking, access radar auto tracking, access perimeter defender auto tracking, advanced active gatekeeper. So active gatekeeper is a PTZ camera set in a preset position when motion is detected in a predefined area, then returns to the home after a set time. Gotcha. Positioning cameras, sharp dome technology. This lets you see as much as 20 degrees above the camera with sharp dome technology. Thermal cameras. Thermal cameras take the color, or they take the temperature and then artificially color it. Explosion protected cameras. These contain the energy of a potential internal combustion. Alright, so camera elements, light sensitivity. There's lux, which is a measure of illuminance. So the lower the lux, the darker. And then again, the lower the f number for lens, the better light capability it has. So there's three different lens types. There's fixed focal length lens, varifocal lens, and a zoom lens. The field of view is the angle the camera can capture. So there's three of these: wide angle lens, normal view lens, and a telephoto lens. So wide angle is going to give a large field of view, normal is going to give similar to the human eye, telephoto, and that is going to be magnifying the field of view, narrower field of view. Can sometimes result in a small depth of field. So f number again is the light gathering. The lower the f number, the better the light gathering capability. So there's different iris types. There's fixed iris, DC iris. Fixed iris is the iris cannot be changed. DC iris, the camera automatically changes. P iris, you can control the size in a much more precise way than DC. Depth of field refers to the distance between the closest and farthest objects that appear sharp simultaneously. This is important in applications where you might need to read license plate at different ranges. Depth of field is affected by four factors: focal length, f number, distance between the camera and subject, and how the image is viewed. So longer focal length, lower f number, shorter distance will all decrease the depth of field. Makes sense? It's the opposite. A shorter focal length, higher f number, and a longer distance will be a increase in the depth of field. If the lens is too big for the sensor, if the lens is too large for the sensor, then you might get black corners. So focus recall and laser focus. I know that's in the test. Has to do with focusing, obviously. It's good in low light conditions. PTRZ precision. Remote PTRZ makes it possible to adjust the camera view from afar. Removable IR cut filter. This is the day-night functionality that cameras have. Exposure control. So there's F number and then exposure time. Backlight compensation. Dynamic range. It's the ratio between the highest and lowest illumination value in an image. WDR imaging again is good for scenes with a lot of a big dynamic range, a lot of brightness and darkness in one video image. Active tampering alarm, useful when there's risk of vandalism. Audio detection, Alright, so that's chapter 3, and then chapter 4 is video encoders. Let's go back to the study guide. So that's the network video technologies. There's also chapter 6, 7, 8, resolutions, video compression, and audio. So let's look at those. Maybe skim through these chapters on the way. Video decoders, video resolutions, here we go. So resolutions, again, is the number of pixels that will be in the image slash video. Aspect ratios, so here's the difference between 4:3 versus 16:9. 16:9, think of maybe a movie theater. 4:3, maybe think of a painting, I don't know, or the square version of 16:9, I don't know. This image is helpful. They have corridor format, useful in retail environments. Video compression technology. So there's H.264 compression algorithms, H.265. This digs into it. It's using frames, I-frames, P-frames, and B-frames to do its compression. There's GOP, group of pictures length, which determines how many P-frames should be sent before another I-frame is sent. This is really getting into it, but it is quite complicated, I can imagine, for compressing video, but it's impressive what they've done. So H.264 compression. It's not just by access again. So there's a baseline or main profile. Zip stream. Access zip stream is more efficient for video encoders, further lowering bandwidth and storage requirements. It uses ROI, dynamic regions of interest, frames per second, and groups of pictures. Another technology for compression is motion JPEG. This is worse than H.264, I believe. Yep. Let's see here. So there's different there's average, variable, and maximum bit rates you can set for access cameras. Variable obviously will vary. The bit rate can vary. Average, you set an average that it shoots for optimally over time. And then maximum is like the maximum bit rate you allow the camera, and that can result in poor image quality if the bit rate goes over that maximum bit rate set. Alright, audio technology. So there's different audio modes. Simplex, in simplex you can only send audio in one direction. Half duplex, you can send and receive in both directions, but it's walkie-talkie style. And then there's full duplex, where you can send and receive, talk and listen at the same time, non-walkie-talkie style. There is Session Initiation Protocol, SIP. It's a widely adopted standard protocol for IP telephony, video conferencing, and call control. instant messaging. I think that's all of it for this first network video technologies. So there's some online courses, some web articles, have some videos that have went over these web articles. Let's see. Let's just keep going through the technical guide, but quickly let's look at the naming convention, the structure for cameras. This is important to know. The extension is important to know, to memorize. So C, climate control; E, outdoor ready; L, LED illumination, good for darkness; R, rugged, good for rugged environments; P, panoramic; S, stainless steel; V, vandal resistant; W, wireless. And then the first number in the number list is the product type. The first letter is the product line. So there's different product lines. There's Q, most advanced; P, versatile and advanced; M, affordable, intuitive; V, live streaming for professional use; I, network intercoms. And then the different product types 1 and 2, you got your fixed box, your fixed bullet, or your thermal cameras. 3, 4, you got your fixed dome cameras. 5, 6, PTZ cameras. 8, 9, specialty cameras. Positioning camera or network intercom. So there's Access has wearable products, video products. They have video analytics, AI that can recognize objects and people, vehicles and people, looks like in this image. Efficient search, efficient operations, license recognition. A lot of benefits from this. Find what you're looking for, proactively prevent, make better use of resources, make informed decisions. So where is the video analyzed? You can analyze on the camera. There's a lot of benefits for that. Using uncompressed data, real-time alerts, easy to scale up, improve privacy. You can do analytics on the server, where you need a lot of processing power. You can do it in the cloud. It's quite costly. Easy to scale, though, or a hybrid solution. So there's also, we talked about this earlier, the Axis Camera application platform, where you can install and run applications on Axis cameras from Axis or third parties. Alright, network. Chapter 12, network technologies here. Been over this before in a different video, so we'll quickly go through. Local area, LAN, local group of computers on one local network. Most widely used LAN is Ethernet, which uses a standard called IEEE 802.3. There's fast Ethernet, 100 Mbits; gigabit Ethernet, it's 1,000 Mbits, 1 gigabits per second. And then there's 10 gigabit Ethernet, 10,000, 10 gigabits per second. Gigabit Ethernet, 1 gigabit per second. Fast Ethernet, 100 Mbits. Yeah. 8 bits to a byte. 10 gigabit can cover distances up to 6 miles. Um, Gigabit, 3 miles with single mode. It's going to be shorter with multi-mode fiber cables. Again, they use power over Ethernet to power these access devices. The benefit here is cost savings. No need to install a separate power line. So it's important though when using power over Ethernet to know how much power you're working with from the power supplied equipment. So say there's a switch, which is the power supplied equipment, that's at 300 watts of power. If it's powering class 1 devices, it can only supply power on 20 ports. Oh, sorry. If so, wait. Unless power devices support power classification, a full 15.4 watts must be reserved for each port that uses power over Ethernet, which means a 300 watt switch can only supply power for 20 of the 48 ports. However, if all the devices let the switch know they're class 1, which is 4 watts, okay, that makes sense, which is only 4 watts, that's all 48 ports that it can power at 4 watts. But if they're class 0, if it doesn't know, it'll treat it as class 0, 15.4. Okay, a midspan. A midspan injects power into an Ethernet cable. It's placed between the switch and the power device. They must be placed within 100 meters. So routers forward data packages from one LAN to another via the internet. A network router must be used. This routes information from one network to another. There's firewalls, internet connections. The just important to know the data transfer and bandwidth between devices on a network. IP addressing. So these access cameras again are assigned an IP address. You can set it manually or by DHCP addressing. So ports, let's go over some important ports here. File transfer protocol, FTP is on port 2.1. Send mail transfer protocol, SMTP, that's on port 2.5, port 25, SMTP. HTTP, it's on port 80. HTTPS, that's port 443. Those are all using TCP. There is RTP, real-time protocol, that can use UDP or TCP, and that doesn't have a defined port. And there's RTSP, real-time streaming protocol, and that's on TCP port 554. So SIP, this is Session Initiation Protocol. This is for peer-to-peer calls, SIP server calls, and SIP trunk calls. VLANs are good for a low-cost, cost-efficient solution to separate networks out virtually. Quality of service is prioritizing network packets within a network. System protection, chapter 13. So many access video products support the IEEE 802.1x authentication. actually taking my access test here pretty soon, hence why I am doing this video. Network isolation, device protection, so using signed firmware, secure boot, access edge fault. This is pretty much the whole text, but oh wait, no, there's a lot more here. There's 18 chapters. We pretty much went through them all though. Bandwidth requirements, storage requirements. So there's lots of different ways to store using an on-premise server, edge storage on the camera, hosted video. There's different types of ceiling mounts: surface mount, mounted directly on the surface; recessed mount, mounted inside a ceiling with only parts of the camera showing; pendant mount, to be hung, the camera is hung; wall mounts, pole mounts; parapet mounts, to mount cameras on rooftops or to raise the camera for a better angle. This image is a example of that. Transparent domes. So the type of dome is gonna affect the image quality. The thicker the dome, more sturdy, but higher chances of imperfections, may create unwanted reflections. There's different dome types: clear and smoked versions. They do reduce the amount of light available to the camera. So there's clear, partially tinted, partially smoked, and then totally smoked or totally black tinted domes. So when positioning the camera in with glass, you want it right against the glass, or else you can have reflections. So IP is a standard that, this is one of the questions that, IP is the standard that labels products with a number to sort of measure how resistant it is to different matter. It's a more basic way to put it. So there's different lenses: normal view, telephoto, and wide angle, different fields of view. 3 types of fields of view: normal view, telephoto, wide angle. H.264 is better than motion JPEG compression. H.265 does not yet entirely fulfill the requirements of surveillance video. This isn't really an issue though, because Zipstream combined with H.264 is very bitrate efficient. Access Zipstream is filtering out low interest areas and compresses them more while recording the details of interest and motion at a higher quality. This switching between a maximum group of pictures value and a lower value drastically reduces the bitrate. Gotcha. So higher group of pictures is gonna be a lower bitrate, and a lower group of pictures I assume is gonna be a higher bitrate with this Zipstream technology. Pixel density on an object depends on how far it is from the camera, which type of lens is being used. Axis offers tools for this. Axis Site Designer. Axis Site Designer can help calculate image resolution and field of view based on the camera's model and position. Identification in challenging conditions for a face is 80 pixels a foot. For identification of a human face in challenging conditions. Axis Companion is a video management system designed to offer easy monitoring of premises, people, and assets. These are video management systems. There's Axis Camera Station. Axis Camera Station offers advanced video management functionalities. And then Axis Companion can be used as a hybrid cloud solution. There's a hosted video management system. Alright, well that's pretty much the whole textbook for the Axis technical guide. We went over everything here, so it's a pretty long one. Where are we at here? 44 minutes. Goodness. Alright, probably stop it here, but maybe we keep going actually. Let's do some practice tests. My test is in pretty soon. My test is at 3. It is 2:12. Check in 20 minutes, so I'm going to call it here, take a little break, rest up before the test. Thanks for going over that. Hopefully it's helpful for you all out there, someone out there going over this access certificate. It's not the best way, but it's a combination of this and taking practice tests will help you hopefully pass the access certificate exam. Thanks.